Uh, before Before I do that, I wanted to mention two activities of the center that are coming up. We are having our continued series of police traffic stops in Waterford and Watertown, Connecticut, I believe. I'm sure Eileen will correct me if I'm wrong, but you can see on the website if you know of drivers with autism or who are trying to get a license and they want to have the experience of actually having a police traffic stop, please come and sign up. The other thing I wanted to mention, it's also on our website, or you can email me directly or Eileen, is we're doing a study of interactions of police officers, personnel with folks with autism spectrum disorders. Parents can complete this as well as individuals with ASD. And we're hoping to really get some sense of what the experience is from the autism side of things. We're trying to do more in terms of training of police officers and to make interactions with police officers go better. So we have a link. It takes about 15 minutes to do. And the link is on our website, but we'd also be happy to send it to you. With that being said, it's great this morning to have my colleague Suzanne Marcari from Yale, who's going to be talking about some of her really exciting work on infants and really young children with ASD. And this is very important in terms of issues of early diagnosis and intervention. Suzanne is a world leader in this area, and so it's a pleasure to let her take it over. Suzanne, it's all yours.
Thank you so much, Fred. Can everyone hear me? Okay, great. It's really a pleasure to be here today, and I want to thank you for inviting me to speak about early development in autism. I'm going to share my screen, and let's see. Thanks. And we'll do this, and also I'm going to flip that in just a second. So this goes away. Sorry. So there we go. There we are. Okay, very good. Okay, so I am a developmental psychologist, and I co-direct the Social and Affective Neuroscience of Autism lab at the Child Study Center. Early development is such a broad topic. It's, something that we could definitely speak about for an entire day or an entire week. And in this lab, we have studied really such a wide range of topics across a range of ages from infancy through the preschool years. And the fact that I'm a developmental psychologist, and my closest colleagues are as well, we approach all of our work with a developmental lens. And nearly everything we have done in our group has been longitudinal. So I will present a little bit of an overview of just some of our work, as well as some of the most current knowledge about early development and diagnosis in infants and toddlers with autism. Of course, in 40 minutes, we can only start to scratch the surface. So this is just a bit of an overview of the different areas that I will cover very briefly. We'll start with autism symptoms, onset, prospective sibling studies, which we have done a lot with, early social communication development, social attention, some a little bit on emotional development and co-occurring conditions. All right, so I am going to start just flashing the autism spectrum disorder criteria from the DSM-5. So as some of you may know, this is a somewhat more restrictive set of criteria that we have over the past decade or so compared to earlier manuals. But even given that, autism is still always a very heterogeneous disorder. And that also holds true for the phenotype in our youngest children. And because autism is a developmental disorder, there is that complexity. Infancy is a period of such rapid growth and change, a lot happens. And so we have learned that the features that characterize autism really do vary quite a bit, and they do change over time. Now, with this audience, I probably don't need to go into great depth about behaviors that characterize autism. So I will just gloss over these quickly. But please note really that the main issue with toddlers and really very young kids is that the differences that we see really manifest in a much more subtle way than we would see in older kids. So you'll see that I use words like limited or infrequent or present, but not maybe combined with some other kinds of communication here in this category of reciprocal social communication and social interaction. And moving on to the second main area are the restricted repetitive behaviors, interests, and activities. We're learning that these behaviors are definitely not specific to autism. They appear in other neurodevelopmental conditions as well. Even in some typically developing children, we see them, particularly the repetitive motor movements, and we have an ongoing study about that currently. We know far less about this category, I think, in the field. It contains a lot of different kinds of behaviors that we kind of assume go together, belong together, but they certainly don't always co-occur in the same children, and they appear to have very different neural underpinnings. So with this, we have a little bit of an idea of what autism can look like in young kids in the second year and the third year. But certainly there is a lead up to all of this, right? We call this the prodrome. So this is kind of the earliest signs that something that a disorder or a condition is developing. And studying this prodrome and the emergence of autism is so important so that we can better understand the developmental dynamics of the condition, identify the earliest signs so that intervention can begin, which is so important, and also to develop more effective treatments. So how do we go about studying this emergence of autism? Well, we can ask parents what they remember about their child's development in the first and second year. And so this is what we did in the field for many years. And based on this method, we have learned about various onset patterns. So it seemed as though there was this kind of early onset with very, early manifestations, and then different kinds of a later onset with plateaus in development, with some delays, and then maybe some losses or some frank losses or regression. But what we can tell from more recent research is that the devil is really in the method. So if you measure retrospectively, or if you ask parents what they remember, chances are you'll get only the most dramatic kinds of regressions or losses. And if you have something more subtle that has happened, that is missed. But if you measure behaviors prospectively, so forward in time, and dimensionally, so you're collecting really raw information about behavior, raw data, then these regressive patterns of development seem to actually be the rule, which is a little bit shocking. 70 to 90% of children who are studied in this way experience really, subtle, gradual declines in social development. These declines can be so difficult for parents to detect kind of in real time as they're happening. And it's difficult for them to identify them categorically as, say, a regression or a loss. So again, this prospective method allows us to really collect accurate information. Parents don't have to judge about what's happening. And the data over time really tell the story. So there are many complexities to onset and then by definition, early diagnosis. So we have really a variable protracted course of onset. All the symptoms that are required for the diagnosis might not be present in the youngest children. And this is true if you're collecting information via parent screeners. It's also true if the infants and toddlers are being evaluated over time by experts, by real clinical experts in the field. We found that there are children who really don't meet the criteria, don't appear to meet the criteria until the age of 3, or even after the age of 5. More rarely, but still, there are some children who fall into this category. We see that specific autism symptoms can really vary a lot depending on other features about the child, say their verbal abilities or their nonverbal abilities. And so it should be no surprise by now to hear that the prevalence rates of autism really increase quite steadily into school age. And here is a nice illustration of that. This is from a Norwegian population-based study of about 500,000 kids. So you see that at the youngest ages, you're seeing some, but not a lot, and really quite gradually and linearly over time, you see this increase up to age 8, which is the age at which, for example, the CDC often pegs the incidence rate of autism. Okay, so more complexity for our toddlers is the DSM-5's impairment criterion. So from the first slide that I showed you, there was this criterion D, which is symptoms have to cause clinically significant impairment in important areas of functioning. And so this is really consequential to the diagnosis of kids under 3, because we have a number of kids who really function in the average range. So for them, their autism may be only very mildly impaired. For toddlers, there aren't many demands on their abilities, right? We have very supportive caregivers, parents, and daycare providers who really scaffold them, who help them along with everything. But then as they get older, the expectations do increase. Impairments become more apparent over time. And so any of these sort of accommodating environments, or again, these abilities that children have already that might compensate for some of their weaknesses, both of these contribute to this phenomenon of a late symptom onset. Okay, so I'll talk a little bit about this perspective approach to studying autism, and Fred will remember this well. The first family history studies were conducted way back in the 1970s and 80s, and it really brought to light the fact that there is a familial component to autism. They saw in these first studies that it was much more common in siblings of people with autism to develop it, and it was even more common in identical twins. So this kind of suspected genetic liability combined with concerns about a delayed diagnosis really led to the beginnings of the infant sibling research design. And so this design offers the opportunity to really get a more precise estimate of the risk or likelihood of younger siblings to develop autism, and to also explore the full range of the variation in the genotype. So we have seen in recent years that through baby sibling prospective studies that the recurrence rate in younger siblings, kids with autism, is about 19%. And this 18.7 to about 20% has been replicated a couple of times in some other larger prospective studies. Now, when we use a slightly different methodology, population-based cohort studies, we see a somewhat lower rate of recurrence for various reasons, but still it's about 7 to 12%. And also siblings have an increased likelihood of developing other developmental problems. And what we usually think about when we think of families who have a child on the spectrum, we see this kind of gradient with about 20% of kids with autism, and then another 20 to 40% of kids who have some developmental issues that may be transient, but maybe more permanent. And then about 40% who are developing typically. And this is, of course, on average. So, following the development of these infants helps to examine the early signs, the kinds of emergence and onset. And, we've been following these siblings and also now second and third degree relatives for almost 2 decades, along with a lot of other groups across the country and internationally. And this is how we've been able to learn so much about the earliest development of children with autism. And hopefully the idea is that with these studies, we'll get to understand the mechanisms behind the development of autism, and we can study it pretty much as it is unfolding. And I just want to say just a quick word about nomenclature. You'll see in some of the older studies, not even older, but maybe even 5 years ago, that we use terms like high risk to refer to this group of kids who are siblings. That has fallen out of favor. We now call it things like high likelihood or elevated likelihood, and there's a host of different terms out there. But you may see high risk in this presentation, but this just reflects, the older terms that are a little bit less accepted now. And just to flag this here, children with older siblings on the spectrum are not the only ones who have a higher chance of developing autism. There are other groups of children in which autism is more likely to occur. So babies, say, with congenital heart disease, or babies born prematurely, especially the ones who are most extremely premature, or with kinds of genetic abnormalities that you see listed here. Because the prevalence of autism is up to about 30 times higher in these kids than in the general population, they are increasingly understood as high likelihood populations. And just a bit of an update, this was just published, the CDC's new numbers for the prevalence of autism in the United States in 8-year-olds is 1 in 36, about 2.8%. Okay, so I'll talk now a little bit about this prodrome of autism, or these early signs that indicate the onset of a condition. And I'll focus on the period from birth to 12 months. So in our work and the work of many, many other groups, we have seen that there are, there is actually quite a lot of evidence of social communication impairments that are evident in kids who will later be diagnosed with autism compared to their peers. So these are kind of the very, typical, impairments that we see in autism in older children. So less eye contact, less communication, like requesting and gestures, joint attention, all of these things. And this is just, a tiny bit of what has been reported. And so the question is, well, okay, so at about 12 months on average, we see that there are these significant issues in social communication. But what about, what about earlier? What about at, say, 6 months? And I'll say that, at the beginning of these infant sibling studies, researchers were really optimistic that we would also be able to see issues and problems at 6 months in social communication. But in fact, almost all studies that have studied social communication behavior at 6 months, almost all have not found any evidence for this, actually. And you see intact eye contact, intact affective responses, intact social reciprocity and attention, intact vocalizations. So this point in time is we had to dig a little bit deeper. So we have limited evidence for any pronounced behavioral signs at 12 months. So what could explain this? What are possible explanations? And these are all perfectly viable. Could be the natural course of autism. Maybe it's just the way it develops, and we don't, nothing is happening until closer to a year of age. We could also have the situation of limited sensitivity of our existing behavioral methods. Maybe we just don't have ways that are fine-grained enough to really detect the differences. Thirdly, we could have maybe an overly narrow idea of what the prodrome of autism could look like. So there's a distinct possibility, and I'll show you some evidence for this in just a second, that the earliest signs may be actually outside the domain of social communication. Remember, social communication is a very complex set of behaviors and abilities. So it's not too surprising that the earliest signs are not in these more complicated areas, but rather in more basic functions, basic processes. So where we have lately seen findings in 6-month-olds that are positive, meaning there are differences for kids with autism, this is kind of the next generation of studies, and we see that development is already beginning to go differently by 6 months. And so this is really going, sort of underneath the hood, going beyond behavior that can be, detected in real time by a person, and into these very basic processes. So we have seen now, and again, this is just a sampling. There are a lot more studies than this, but we've seen atypical habituation and different electrophysiological responses to things like gaze. So a picture with someone making eye contact, or even facial information. We have an FNIR study that shows reduced activation in the brain to social stimuli in the kids and babies who will later be diagnosed with autism. We have EEG studies with whole brain states that reflect periods of synchronized network activation. And these are different in the babies who will later be diagnosed with autism. So a lot of really interesting, fascinating work here in our lab and in many others where we use a technique called eye tracking to measure attention. We have seen all different kinds of limited attention, limited spontaneous, selective attention to social stimuli when they have a choice of what to look at on a screen. Then there are the brain studies, atypical development of white matter, cortical surface area, increased cerebrospinal fluid. And then even, again, from our group, growth patterns, head circumference, skeletal growth that begin even prior to 6 months of age. So what all of these studies are telling us is that, as early as 6 months of age, perhaps even sooner, we are seeing these kind of very early biomarkers or processes that are at the level of the brain and not at the level of behavior. Now, this slide focuses on 6-month-olds. Now, of course, we have to go even earlier. There are a couple of studies now published on 3-month-olds, different EEG connectivity patterns in the babies who develop autism. In our own work, we had an Autism Center of Excellence here that we were part of. We studied newborns, and we saw differences in resting state functional connectivity during the first 4 weeks of life. Really, really exciting work that we've been able to be involved in. And of course, we're following these newborns over time and over development. So we're hoping to get, closer to mechanisms as we even get younger and younger with the babies we study. Okay, so in our lab, we have really specialized over the past 20 years in the study of endogenous or kind of top-down attention to social information. That's just a fancy way of saying, what do you choose to look at when you're given a screen with a video with an array of different things happening? And our studies have shown significant differences in attention by 6 months of age. And we had one of the very first studies to show this at such an early age. So how do we measure attention? Well, we have to go again back to ancient history to a Russian psychologist, Alfred Yarbus, who observed that visual scanning is this process of trying to seek relevant information from the environment. And he conducted some of the very first research using eye tracking, recording gaze patterns of adult participants. And so now we have been able to use the more modern version of eye tracking with great success in the lab. Again, tons of other labs use this as well. We study nonverbal children and infants as they explore visually. These paradigms where a baby sits in front of a screen in a car seat close to the screen, but there's nothing attached to them, nothing attached to their eyeballs. It's all very non-invasive. They need to just sit and watch while this infrared camera at the bottom collects information about their gaze position. So it's a really nice, very versatile tool to be able to study things like perception and attention and cognition. All right, so when we wanted to, try to study something like social attention, because it seems, to be quite related to the phenotype of autism, we wanted to see how young we might observe some differences in our high or elevated likelihood siblings. And these were 6-month-olds. So we devised a task that some of you may be familiar with. Some of you may have seen this before because it's a task we've used for many years. It's somewhat naturalistic. I'll say somewhat. It incorporates a few different kinds of scenes or conditions so we could examine the effects of context on social monitoring. So we created this video with this nice woman who speaks and looks into the camera, makes some sandwiches, does a number of things with the toys. And I'll just show you a quick clip of this. And the little green dots are where kids are looking, by the way.
Hi again, sweetie. How are you doing? Are you having fun? You look so cute today.
So you see with the green dots, most of the children who were a part of this sample were looking at her face while she was speaking. Okay, so what did we see in the babies? We saw that the 6-month-olds, who were the bars in blue, these are our kids who developed autism later, they spent less time looking at the scene in general. They just, spent more time, a little bit more time looking away from the computer, looking around the room. But when they did attend to the scene, they looked less at the person, less at the face, and more at the background. And so what can we learn from this study or a study like this? The stimuli were complex. It puts demands on your visual attention, and you have to kind of adjust to what's happening. And then because it's a free viewing task, the performance really captures, a combination of top-down and bottom-up influences. So there's still speculation about what the mechanisms are, right? It's not clear if there are some issues detecting and prioritizing the social stimuli, recognizing what's important in the screen. Maybe there's limited reinforcement value to the person in the screen, or maybe there's just an overall difficulty regulating attention to a scene that is very complex. And to follow up on the work using eye tracking, we also developed a task for a live interaction so that we could see whether what we were observing in the eye tracker was also something that was happening in real life. There could be differences there. So we had 6, 9, and 12-month-olds from our high likelihood, and you'll see it says high risk, low risk, but our high likelihood and low likelihood cohort. We developed what we called social orienting probes. We had 5 one-minute probes that were standardized with an examiner. And in this 5 minutes, first, the examiner spent a minute just speaking to the baby, saying, "Hi, baby, how are you?" I'll just play you a quick moment from this. So much bigger since the last time I saw you. So just speaking to the baby right in front of her, and then singing a little bit of a song, like a nursery rhyme song, playing peekaboo, showing a toy and playing with it, and a little kind of tickle game. And so what we found here was pretty interesting. We found, so on the left, on the y-axis here, we see the percent of time looking at the examiner's face. And what we saw was that, not in every condition, but in two of the conditions, the infants in the dark blue, who later developed autism, spent less time looking at the examiner's face than the kids in the other groups who were high likelihood with complex outcomes, high likelihood who were typical, and low likelihood who were typically developing. And so interestingly, we kind of mirrored the same results that we saw with the woman in the actress in the video with the speaking to the babies and making a sandwich. So dyadic bid, this is a fancy term for just talking or speech. So we saw the same thing in the 6 to 12-month-olds, where they were looking less when the person in front of them was just speaking with them, just speaking gently in a friendly voice. We also saw some reduced attention to the person's face during the tickle probe. But yeah, during things like peekaboo and song, this was quite intriguing. We didn't see any significant differences. So that's quite an important thing, because I think these interactions that contain songs, nursery rhymes, or games, these are highly ritualized. These are really familiar, fun, very salient activities, and these attracted social attention equally across the groups. So this was the first study from the prospective infant sibling studies to document this autism-specific difficulty in attention to faces during this prodromal stage in the context of a live face-to-face interaction. So this was different than what we had seen previously in some of these other studies. So what could have led to these results compared to the previous work that had been done? So we have to try to reconcile these discrepancies. So there are a number of factors here, I think. Even thinking about eye tracking and the live study, the granularity of measurement, right? So when we use eye tracking, we're getting data from millisecond to millisecond. When we are collecting the videos and we're coding them second by second. So this is a very granular kind of measurement. When a clinician interacts with the baby, they might make a global rating of the overall kind of behavior. It might have, might be graded on a Likert scale from 1 to 5 or something, but it's still, it's less granular than what we do in eye tracking or in these behavioral coding studies. The social measurement context is different from some other studies. So these are two very social types of interaction, and some of the other studies that I mentioned earlier were based on kids' behavior while they were kind of playing with toys with someone. And then there's this unfamiliarity of the social partner. So a lot of those previous studies had the mother as the social partner. Now, in these two studies, the person interacting with the baby was a stranger. So the actress on the screen was a stranger, the examiner was a stranger. And we think that it may have to do with familiarity. So the mom, a mom or parent, father, they have a long history of interaction. They're very familiar to the baby. This could help kind of scaffold and help, make what could be more fragile social attention seem, very much normal. Also, we're not sure about this because this is just a guess, but it could be that parents of elevated likelihood infants, they might utilize strategies to enhance their baby's attention and affect. And this actually has been shown in at least one study. And in our studies, neither the examiner nor the actress on the screen does this in any way. So these could be factors that lead to these differences. And now in a more recent study, which is very intriguing to us, it showed that there was actually unusual functional connectivity during speech processing in autism. So that, kind of could be part of the explanation of why when kids with autism are faced with someone speaking to them, they are not as attentive. So, we're looking to understand the mechanisms, and so this study was quite intriguing for us. Okay, so taken together, we see that there is this limited attention to faces and for people trying to engage with eye contact and with directed speech. And this could really have a vast impact on development of social cognition and communication, and in the specialization of these networks that are involved in processing social information. Young infants learn about the world primarily through looking and listening. So if attention is different very early on, it's likely to impact development of these systems and have cascading effects across development. And just to note that, it seems as though infants with autism are already kind of constructing their own, different social environment because of the way that they're deploying their attention differently. Okay, now I'm going to switch topics a bit to emotions and autism. This is something that we have been quite interested in and invested in the last several years. Because they're so important. Emotions are very influential in terms of development, learning, mental health, physical health. And a common picture of the emotional lives of kids with autism is one where negative emotions are very prominent. So kids with autism have difficulty regulating their emotions. They may be anxious, they may be sad, they may have tantrums. And so there has been a fair amount of research in this area on negative emotions. But we know very little about the positive end of the spectrum. And this is really a huge gap in knowledge because positive emotions like joy are so important. As we experience positive emotion, we have increased levels of neurotransmitters like dopamine in the brain. This is important for motivation, learning, and reinforcement and problem solving. We know from the general infant development research literature that joy is related to sociability, related to overall adjustment later on. So this is a very important area. And so we designed a study quite a while ago about to examine how toddlers might experience emotion in everyday situations. It's a lab-based study so that we can standardize what happens, but these tasks that we have kids do are fairly naturalistic. And the results were very different, very, a little more complex than we expected. Now, I don't have time to go over all the results in all of the conditions, not the negative conditions, but I wanted to focus on this joy condition. So this is very, very interesting. When we presented things like a puppet show or bubbles to kids, and these are 18 to 24-month-olds, we observed actually a very similar intensity of smiling, laughter, and excitement in toddlers with autism compared to their peers. And this, based on review of the literature, was somewhat unexpected because there was this, kind of anecdotal and some other sorts of studies where it seemed that kids with autism were less joyful, less positive, and more negative. So during these situations, these are just your typical fun, fun play tasks for little kids, like puppet show. There was a lot of positive affect. And this was, vocal affect, facial affect, bodily affect. And what is important to note here is that we designed the tests specifically to be non-social because we wanted to not confound the socialness of a situation for the kids with autism, because we knew that they already had some difficulties there. So these are just non-social. Display of fun toys, puppet show, bubbles, a little roller coaster with a penguin that went around and around. No interpersonal interaction was required. And we think that this is actually key to our results. And now we looked at, also we focused in on this puppet show task because it was especially fun, I think, for all of the kids. There were no social demands. And we're working on a small study with one of our research fellows where we're looking at the shared positive affect. So how often did kids turn and look at their parent and smile? And it turns out that the kids with autism, this is still kind of in progress, but preliminary results are showing that perhaps they're not so different from the typically developing kids when there aren't any social demands placed on them during the activity. So the puppet, the fact that these are puppets is something that we wanted to kind of develop a little bit further. So the puppet activity seems to almost be a normalizing context where the kids with autism are experiencing emotions and sharing them. Why this response to puppets? What do we know about puppets? Well, we had heard some anecdotal reports that children with autism might be actually highly interested in puppets and puppet characters. And this study that I just described suggests that. Of course, these were very simple basic hand puppets that we use, but again, this seems to be a source of great pleasure for kids with autism. So we actually partnered with some professional puppeteers and the Jim Henson Foundation to create stimuli for a study. And in the study, we presented preschoolers with and without autism with a brief video in the eye tracker where a person and a puppet engaged in a conversation. So I'll just show you a quick snippet of this. Very cute. So this is a very, very engaging video that goes on for a couple minutes. And so what we found was really, really neat. So as you see on the left, when the human was the one speaking during the conversation, the kids with autism were basically at chance with whether they were looking at this person or not. And this is, again, replicates a lot of other studies of ours where children with autism are just not looking as much at a human speaker compared to the typically developing kids. But when the puppet was speaking, this is where the kids with autism look just as much at the puppet as the typically developing kids. So high levels of attention to the puppet's face, just like the typical kids. And also a very important finding, which I'm not showing here, is that the amount of preference for the puppet speaker was not associated with the severity of the child's autism symptoms. So what that means is that the children who were more severely impacted by autism were just as likely to attend to the puppets as those who had less severe symptoms. And that is absolutely not what we have seen with the human speaker. It's usually quite related to the level of autism symptoms. So these results are suggesting that maybe puppets can be a very effective way of introducing, to help kids in therapeutic settings, introducing social communication and helping them learn. So, interacting with puppets may be an intermediate step in some ways to develop better engagement skills with human social partners. So this is really, this was a really fun study to do and very, very interesting and exciting. So, taking the puppet study and the emotion study together, there are ways to enhance attention and to enhance the experience of joy in young kids on the spectrum. Puppets being, one avenue, other enjoyable activities that maybe are not so heavily socially loaded that could serve the same purpose. Okay, and then the last thing I will get into just briefly, because I know I'm just about out of time. Oh, aren't I out of time? Okay, I might be out of time. Co-occurring conditions in autism. I will just flag this very quickly, just to say a few words that, the magnitude of co-occurring conditions, children with autism is quite high. About 70% of kids are impacted by some additional disorder, anxiety, ADHD, externalizing behaviors, and just as often kids might have multiple conditions at once. And so this is not only in school-age kids, this actually goes younger, where we see kids in the preschool years having more anxiety, more significant ADHD-related symptoms, which are, of course, very impactful for their social adaptation, for daily living activities, and the development of further behavioral problems. Executive functioning is also an area that we have taken an interest in. These are the functions about controlling behavior, remembering things, completing tasks, inhibiting inappropriate behaviors. Impaired executive functions are already present in preschoolers with autism. And in our study, we found that half of our 3-year-olds showed clinically significant executive functioning deficits. And that was across a range of different subscales in the general composite scale. This has a massive impact on things like school readiness, adaptive functioning, other areas. So the question is, with these high levels of behavior problems for kids with autism, we are interested in finding risk markers again in infancy. We already know that by the 2nd year, kids with autism are experiencing broad internalizing symptoms like depression, anxiety, and by preschool, internalizing and externalizing symptoms. And even the siblings of kids with autism are experiencing more of these problems. So if we can identify risk markers of these early problems, we could improve early intervention and prevention efforts. And then finally, we know that in the general population, there are such precursors of emerging behavior problems, and they happen to be in the area of atypical emotional reactivity, like distress or anger or especially high or especially low levels of joy, predicting later problems. And so, because we know that these emotional reactivity predictors of later problems are, the research is limited, we were awarded, or we applied for funding, and 2021, we got funding to study this in infants with family history of autism. So hopefully with this study, we'll be able to predict who among them will have greater difficulties by early preschool with things like anxiety, depression, oppositionality, a whole host of behavioral problems. So I would like to, with that, end and thank this is my current large team at the SANA lab, a group of wonderful, brilliant researchers, clinicians, and staff and fellows. And it's a pleasure to work with all of them. And I also have to acknowledge all my other collaborators, past and present. It takes a lot of people to do longitudinal work, a lot of people and a lot of time. So I should also acknowledge our funding sources and, of course, all the families and kids who have participated in our studies. And I am also going to just I'm going to flash this on the screen. This is a very shameless plug for our study that I just mentioned, in case there's anyone in the audience who might want to pass along this information about the study. And if you use that QR code, that should lead you to our inquiry form. And I can also, let's see, on this last page, I think the little QR code will lead to our research page on our website. So you can go from there and also get to the inquiry form if anyone is interested. So I know I have not left much time for questions, but happy to take questions.
Thank you, Suzanne. So we do have a couple of questions. The first one came in earlier in the program, and they were asking, what did the head circumference study find?
What did the head circumference study find? There are a couple of studies from our group and from others that have shown that in a subset of kids who later develop autism, there is a quicker increase in head circumference size over the first year. And it starts pretty early. And I believe that other studies of kids with autism have borne this out. Of course, there some studies, depending on methodology, can show something, things that are different than that. But the head circumference studies are interesting because to some extent it can be familial. So if a child has, a larger or quicker rate of head growth in the first year and ends up with a head size that is, somewhat on the larger side, this is also, there's a familial factor to that too. So parents may also share that same feature. So in that sense, you can see it as almost an endophenotype. There is some work being done on stem cells at the Child Study Center from kids who fall into this very high, head size range called macrocephalic. So this seems to be a subtype, perhaps, of autism, where kids tend to be more severely impaired. Of course, not all kids with autism develop in this way, but it seems to speak to a bit of a subtype.
The next question that came in was asking if peekaboo and tickle have more exaggerated prosodic.
Prosody.
Thank you. Salience than other attempts.
Peekaboo and tickle, sure, certainly. So, right. So, definitely. So peekaboo, I think, has a lot more visual cues, right? Because you have your hands, you're using hands. Remember, the peekaboo and the song were the ones where the tests where the kids with autism were actually quite similar to their peers. So it could be that these were more, kind of attention grabbing, although the song, the only thing that was different from speech was the fact that it was singing. So there were no hand movements or gestures or anything with the song. So that's something to keep in mind. Tickle, we think that was also, an interesting result, that the children with the babies with autism look less at the face during tickle. There could be multiple reasons. We think that there may be a multisensory aspect to a tickle game that is perhaps more overloading, or more, it just takes more resources to process that. So you have hands that are, coming at you, and eventually, just gently, a gentle little tickle under the chin or on the belly. So that might be more stimuli than the child can then still manage to kind of check in back with the examiner's face. But yeah, each probe, I think, has, some particular feature that helps explain, perhaps what's going on.
We have one more question, but before I answer that, people have been asking, and yes, the recording will be on our website along with the slide deck, most likely later next week. So please just check back there. And the last question we have is, what did you or your researchers discover about a child's sensory integration processing capacities?
That is a very interesting question. This is maybe one of the topics in early development autism that we have not really studied in any detail. So I probably can't speak as much to that. We don't, we don't have any paradigms that tap into this, or any, information that we get about that topic. So sorry about that.
Are there any more questions for Dr. Marcari? I just wanted to announce that we will not have a Science of Autism in April. Our next program will be in May, and you can register that through our website and through the links for these programs. Oh, we just had one more come in. It's do you have any studies for teenagers?
So currently we do not. We finished a study that did study school-age kids and teenagers using fMRI, but that study has ended. But we can refer you to some colleagues at the Child Study Center who do. So if you would like to stay on, we can probably just share that information with you quickly.
Suzanne, thank you so much. It was a fantastic presentation. It's wonderful to see so much work. And I should mention, or maybe I should ask you to explain, Suzanne, our paper on the puppets has just won an award.
Yes, our paper on the puppets has just won an award. This is the Nancy Staub Publication Award. We were quite surprised to hear that this exists, but there is the World Puppetry Association, or actually the acronym is UNIMA, USA-UNIMA, and it's the oldest theater organization in the world. And they focus nowadays on puppetry. And every year they give out awards that focus awards for publications that are relevant to puppetry. And so we have been chosen as one of these several awards being given at the end of the month. So that's super exciting.
Congratulations. So thanks to everyone for coming. We look forward to seeing you again in May. Remember that April is the Autism Month, and we're delighted to have you come visit us or come visit our website. We're also delighted to have your support, both personal and financial. So thank you very much. And we'll see everyone again in May. And thank you, Suzanne. This was a fantastic talk.
Thank you for having me.